Hello, this is Stéphane Bourget. Today we are going to do part number 2 of how to plot a graph on Excel. If you remember, in the first video we saw how to set up a table with the data that you collected during the experiment. And we're going to base ourselves on this information that we got from that we already input in the Excel spreadsheet. So let me just go there, and here it is. So here you have the Excel spreadsheet that we built in video part number 1, and we're going to build a graph based on this information. So how do you do that? Well, first of all, just to give you a context, in case you didn't saw the first video, essentially we did an experiment where we had a metal ball rolling on the floor after leaving a platform, and we essentially want to verify if this ball is rolling with a constant velocity or not. So for that we're going to plot the position as a function of time, and we'll see if we get a straight line or not. Okay, and if it is a straight line, well, then we know that the slope is constant, therefore the velocity is constant. And in this case, we had position with its uncertainty, and we also had multiple measures of the time at which the ball reached different positions, and we could calculate an average of those different times, so we could get a better value and a better uncertainty. So to build a graph based on that, we're going to select an empty cell, and then I'm going to click the Insert tab, and then I'll go to the little icons for graph, and I'm going to select actually the one that you see here on the screen, that is a scatter graph. So I just want a cloud of dots, nothing more. So I'm going to select the first one, and I should get my graph. Here it is. So of course here it is blank, and that's exactly what I want. I am going to fill this blank graph as we move forward, but that way I'm sure that I'm going to have exactly what I want. What I want to do first is to actually place this graph besides the table. I don't want to be over the table because I need to go back to the table to select some data. And in Excel, if you don't care about that, well, then you won't be able to select the data, and you will have to close everything and do it again. So so that's the first thing I want to do. Now I need to select the data I want to plot. So click on the graph. I'm then going to go to the tab that is called Chart Design, and I'm going to select data. Okay, and there, of course, that could be a little bit different on your system. I'm using Mac here, so the windows are not exactly set up the same way, but you should find your way. It's essentially the same instructions, just presented differently. So here I'm going to add a series. So I'm going to click the plus sign, and I'm going to give it a name. This is going to become the title, which I can change afterwards. So for now I don't really care what I'm writing there. Maybe I'll just write let's say measuring the velocity of a rolling metal ball, something like that. Okay, then I'm going to select the x values. In Excel, x means horizontal, but in our case horizontal values are the average time. So I'm going to select cells from H3 up to, or actually down to H8. Okay, and I'm only selecting the numbers, the values, not the titles, not the heading. Then for the y values, I'm going to select the vertical values. So in our case, it's not y, it's x. Position x is on the vertical axis. So my y values is my position x. So I'm selecting the cells from A3 down to A8, and then I'm selecting OK, and I've got a first graph that I will need to edit, okay, because it's not properly edited this way. We need to make it better. So now that I have my data points, I want to add error bars because my values have uncertainties and that should be represented on the graph. To do that, selecting the graph, I'm going to click Add Chart Element under the Chart Design tab, and there I can select error bars and then more error bar options. Okay. Now I have standard error bars on the graph, but they are wrong. I mean, they don't represent the data that we actually have, so we need to adjust that. Currently, I am under the vertical error bar options, so I'm going to first select no cap as the end style. And the reason for that is that oftentimes our uncertainties are very small, and although it would be fine to keep the caps for large uncertainties, when uncertainties are small, they become annoying because the t's, the caps that you see, might become larger than the error bar that is perpendicular to the one we are considering. And then it becomes harder to evaluate what is the actual uncertainty on the data points that we have. I mean, so that's why we have to adjust that. So no cap, and then I'm going to select custom for the error amount. Okay, all of that is under the histogram tab in the options. So custom, specify values. I am working with vertical error bars, so that means that I should work with the delta x, right? The absolute uncertainty on position. So that's what I'm selecting, C3 down to C8 for both positive and for positive and negative error values, because we have the same uncertainty on both sides of the central value. So I can do the same thing twice, or I can just copy what I have in the first box here and paste in the second one, because that should be exactly the same thing. Okay, so now my vertical error bars are adjusted. Let's do the same for horizontal error bars. So I'm going to select them by double clicking on the horizontal error bar. And see, now I'm under the histogram, under the horizontal error bars options. So same thing, I want no cap as the end style, and then I don't have a fixed value for the absolute uncertainty. The value changes depending on the data point I'm considering, so I'm selecting custom, and then I'm going to select the specific values in the table. And in this case, on the horizontal axis, we have time. So that's delta t over here that I have to select between J3 and J8. And again, I do the same for the negative error values. And now I'm done. Now, if you look at the graph, you will see that, oh, sorry, let me put the title back where it should be. So if you look at the graph now, you see that I don't really see my error bars because they are small. Well, I see some of them, but not all of them. And that's the problem with having markers on a graph. If your error bars are too small to be seen, well, that's fine to have a dot as a data point, because you want to know where is that data point, okay? Although I would make those data points smaller in that case. But here I know I can see those uncertainties, but they are hidden by the markers that I have. So I'm going to remove those markers, those little dots that we see on the screen. So I'm going to double click on those dots, and you see I'm going that way to Format Data Series options. And if I go under the paint can, under the marker option, and then if I select marker options, I can select none instead of automatic, and that way I remove those blue dots, and I can still see where are my actual data points because they are the crossing of my error bars, and I can see those error bars. So that's fine. I don't need those markers. They are useless. Um, so, all right, let me close this window. Now, the next step would be to have a trend line. We have data points, we have the error bars, so what is best fit that corresponds to this data? Well, at first, from what I see, I expect to have a linear function fitting this data. So I'm going to go to Add Chart Element, again under the Chart Design tab, and I'm going to add a trend line. And that will be a linear trend line, and that's what Excel gives me. Now, because this trend line represents the best fit, and that's well, so that's the best fit, and I'm going to use later a error line to evaluate the uncertainty on the slope and on the intercept. So I want to distinguish those two lines, so it's nice to have different ways of representing those lines. Here I have a dash line. I want to save that for my error lines, or error line, depending if I do one or two, but I would prefer to have a full line for the best fit because that's what is going to attract my attention, and I want a full line for that. So let me double click on this best fit, and under the paint can I can go to dash type, and I'm going to select a full line as a dash type, and now I'm happy. Although it's a little bit thick, so I'm going to reduce that to only 1 point. I think it's better. Okay. So let me just verify if everything. Yeah, okay, everything's all right. All right. So I got my best fit. Now I would like to know what is the equation of this line. So let me go under the histogram tab, and I'm going to select display equation on chart. So I check that, and then I have my equation. Fine. Now this equation is naturally set up properly. I mean, the equation is right, but in this experiment we don't have y. We have an x, but not the x that is in the equation. That's another x. So let me adjust that. Y is actually position x, so that's where the x should be. And x, actually in my experiment, is time. So I should write t for time. Now, it is a norm in presenting graphs that variables should be in italics, and oftentimes we also make them bold. So let me just select those variables, and I'm going to do that. So going under the Home tab, I'm selecting italic, and I'm going to make them in italics as well. I mean in bold. So bold and italic. All right. Now the other thing is that my numbers in this equation have units, and I should indicate those units in my equation. So in this case of the slope is essentially delta y over delta x, but in my actual experiment, what I have on the vertical axis is position x, and what I have on the horizontal axis is time t. So my slope is actually delta x over delta t. That gives me meters per second. So that's the units that I should have there. And let me put this this value between brackets so it's easier to read, just like what I'm doing now. Same thing for the intercept, except that the intercept is essentially something you add to the slope times time t. So you see that what you end up with is meters, and that's what you expect, because essentially you are calculating a position, right? And that position is in meters. So it just makes sense to have the intercept in meters. That's where the line intersect with the y axis, and in our case the y-axis is x in meters, that's position. Now you might not see why I'm doing that now, but I said earlier that I'm going to have a second line, a error line, so I want to distinguish between those equations. So for this best fit, this best trend line, I'm going to indicate or to put a subscript, and I'll write best to indicate that this is the best fit. So let me put that in subscript. So if I select this word, then I can right click and click font, and there I can select subscript. Okay, and now I am happy with my equation. Let me put it somewhere on the graph, and now let me move to the next step. Well, before getting into the error line, there's still some things we should do with this graph, because you see numbers on the axis, but they are not even labeled. So that's something that is very important to do, because we want to know what we're talking about, right? So clicking on the graph, let me go back to chart design over here, and then add the chart element, and let's select data labels, and oh no, pardon me, it's not data labels, it's axis titles. So primary horizontal and primary vertical. So horizontal, what is that? Well, let me just add the primary vertical at the same time. Okay, so now we have both. What is on the horizontal axis? That's time t. So I'm going to write what this is in full word, so I have time. Then I'm going to indicate the variable, that's time t, so that's the variable. I'm going to put that in bold and italics again, and then I'll indicate the units, in this case seconds. Okay, so let me go back to put that in bold and italics. I go home, bold, italic, and I'm happy. Okay, let's do the same for the other axis. In this case, we have position x, and that's in meters. Okay, so again, let me select x, and let's put that in bold and italics. Okay, now I already have grid lines, which is a good thing, but if I want to be able to read more precisely, maybe I should add secondary grid lines. So going to chart design, add chart element, and here I can select primary minor horizontal grid lines and primary minor vertical grid lines. Okay, just like that. Okay, so now if I want to read the value more precisely, it's easier to do so. Now the other thing I should check here is my axis and the way my graduations are set. I'm already happy with what Excel is doing here. We just want to make sure in general that it's easy to read the values between the main marks. Like I have 0, 0.5, 1, 1.52, but I have two, well, and each interval is divided in 5 intervals, so I know that I have 0.1 for each secondary mark, secondary division. So that's fine, it's easy to read. And that's the kind of thing we want to check. We want to make sure that it's easy to read in between values that are given on the graph. If it's not the case, well, then you need to adjust that. And also, if you have a portion of the graph that is blank, well, we don't like to have useless space in the graph. We want to maximize the space we use for the curve or for the lines, because it just makes things easier to read, and we can make readings more precisely. in this case it's already correct, so I'm not going to change that. But if you need to adjust the axis, you can double click on them and you will have this format axis option window, and there you can set the minimum and the maximum bounds of the axis, and you can also change the units for the major and minor divisions. Okay, so that's where you do it if you need to. Now the other thing I have to check is sig figs. You see, for position, this largest amount of sig figs that I have is 3, so I should have the same on my graph. And actually, more precisely, I should look at the decimals. So the largest amount of decimals that I have here is actually 2 decimals. So that's really what I should take a look at. For time, it's the largest amount of decimals that I have is 2, and that's not the case here with this axis. So double clicking on this horizontal axis, I can go to the options, and under the histogram, if I go down to the number tab, clicking on that, I can select the number of decimal places, and there I want 2. Okay. All right. Now the numbers on the axis are set up properly. Okay. So now let's take a look at the title. I want the title as not something like position versus time, or that's not something we really like, and we don't want variables in the title. What we want is actually something that describes what is the purpose of the experiment. And we also need to number the graph. So in this case, that would be graph 1, and the title, which I can adjust now, could be something like measuring the velocity of a rolling metal ball on Wednesday, I mean, we can precise the date or the group to be a little bit more precise, but something of that nature. I mean, what is the purpose of this experiment, of this graph in particular? It is to measure the velocity of a rolling ball, right? And we'll do that just looking at the slope of the best fit, and we'll need the other slope of the error line to get the uncertainty on that best slope. Okay. So measuring the velocity of a rolling metal ball on Wednesday, and actually I don't remember. Let me just find. Well, it's not really necessary, but let me just invent a date. I don't even know if it's a Wednesday, but let's say Wednesday the 25th of September. Okay, something like that. All right. Now, with that graph, I said I needed a error line because I want to know what is the uncertainty on the intercept and on the best, on the slope. So to do that, I'm going to go back to the table, and I'm going to add a column that is not going to get into the lab report. It's just a column for me to do the graph. Okay, and I'm going to let me give it a name so I remember what I'm going to input in that column. So let me merge and center those two cells, and let me write something like let's say endpoints for position. Okay, let me format the cell so we can adjust the alignment. I'm going to wrap the text and to center the text at the same time. All right, so what I'm going to do there is to invent new positions for the first and the final time. Okay, And I don't really care about the values at this point. I just want to add a new line on the graph, and then I'll adjust this line to make sure that it makes sense according to the data. Okay, so let's say let's say I want to find an airline that has maximum slope. So that means that the position at the initial time, 0.04 seconds, should be lower. So let me try 0.9 meters. And then for the position at the last time that I recorded, 2.74 seconds, let me try to find something a little bit higher. So let me try 6.1 meters. Okay, and we'll see what that gives us. Maybe I'll need to adjust. No big deal. Okay. So going back to the graph, I'm going to add a new data set. Okay, so I'm going to chart design, then I select data, and then I'm adding a new series. I'm going to call this one error line. And for the x values, which is time, I'm going to select only the first and the last time that I recorded. Meaning the average time, because we recorded each of those times multiple times, so we could compute an average and a yeah. So that's what I'm going to select. I'm using the command button to do that. So I'm selecting the first one, command, and the last one, and that's all. Enter. Then for the y values, in our case that's position x. I'm not going to select the real positions because I'm not plotting the actual data. I'm just plotting a error line with my invented values of position. So I'm going to select the first endpoint and through the command button, the last endpoint. Click OK. Now I have a new line on the, not a new line, but I have two new data points on the graph, which I don't see because remember, I removed the markers. So they are there, but they are hidden. Nevertheless, I can then go to add chart element again, and I can add a new trend line. I want a line, a straight line that will be a linear fit, and I'm going to select the series for the airline to do that. Okay, so here you go. You have this new line. It is dashed. That's how I wanted it for airlines. I want it dashed. Now, is it the right line? Well, maybe we have to adjust a little bit the values we invented to make it right. Now, on this very small graph, it's a little bit hard for me to actually read the values and to evaluate things properly. So what I'm going to do, and that's actually something that will be useful also when comes the time to print the graph full page, I'm going to move that to a new sheet. So move chart, I right click, then I click move chart, then I move that to a new sheet, chart 1. And here you have the graph. Now, let's take a look at that. Essentially, you can imagine that the error bars form a rectangle around the central data point. And essentially, you want the error line that fits the data so that touches as many rectangles as you can. But actually, you want the worst case, right? We have the best case, it's the trend line, but we want the worst case. In this case, we want the maximum slope for this line, but that we still want to fit the data, okay? So if possible, we want to touch all the rectangles, but that will be the limit case. If we cannot touch all the rectangles of uncertainties, well, that's fine. It can still be, it can happen. It can still be a good error line. We just have to have a good judgment about that. And if some data points are not touching the line on the right, we should have something similar on the left. That should be balanced, equilibrated. Okay. So in this case, I feel like the upright end of the red line could be a little bit higher because you have this rectangle here, and therefore that could go higher, and this one could go lower. And we'll see if we still match the other data points if we do that. So let me go back to the sheet with the table, and we said let's decrease the first endpoint and let's increase the second one, or the last one, and we'll see what we get. So going back to the chart, well, okay, that's still good for the first endpoint. What about the last one? It looks like it's not touching, but actually it does, but it's limit. I think it's just as I want it. And if I look at the intermediary data points, the line still touches the rectangles of uncertainty, so I'm comfortable with that. I just need to improve the first endpoint. So going back to the sheet, let me try 0.75. We'll see what we get. Okay. Yeah, okay. This one is good. This one, well, it's limit, but if you imagine the rectangle, it still touches the rectangle. But because it's limit here, I don't think I should go lower on this end. So we'll call this error line the actual best choice for the maximum slope. So double clicking on this error line under the histogram, I'm going to display the equation. Okay, so here's my new equation, and I'm going to do the same thing as for the best fit. I'm going to adjust the variables, put that in italic and bold, and add also the units to the values that you have in the equation. So in this case we have x, but that's for the error line, so I'm going to call that x error. Let's put error as a subscript, so right click, font, subscript. All right, then on the other side it's not x, it's t, and let me put that in bold and italic right away. So go home, bold, italic for time, doing the same thing for x, bold, italic. Now let's add units to the values, and let's put that in between brackets. So the first value is in meters per second, and the y-intercept is in meters. When I'm saying the y-intercept, I am actually referring to the y-axis for Excel, which in our case is position x. Okay, don't be confused. Okay, now I'm pretty much done. What you might want to do, if you choose, and that's more something that's more optional than your stuff, is, well, you can adjust the size of the values and of the title and of the labels to make it easy to read. So that's something you can do, and you can also change the font of what is written. In this case, I'm using Calibri, but actually I don't like it very much. I prefer serif fonts like Times New Roman. I feel it's easier to read. So that's something you can do if you want. Okay, so let me just show you how to do it just to finish. So let me select the title. Let's put that in Times New Roman, and let's make it bigger. Okay, 18 is not that bad. So I mean, I can readjust the well, can I should be able to readjust, oops, the anyway. Okay, let me just make it a little bit smaller, 16. Oh, okay, we're going to lines. All right, so that's my title. and then you see you have the equations. If you want to make it bigger, you can also change the fonts. So let's make it 14, and I'm not sure it's going to work on my computer. Normally, you see, normally I select Times New Roman and that becomes Times New Roman, but for some reason on my Mac it's not really working for the font, so I'm not sure why, but it should probably work on your system. So let me do the same for this other equation. Times New Roman, and then 14 for the size. Okay, and you can do the same for the labels. So actually you see that if you just select the whole thing, you don't have to select things inside the rectangle. You can just select the whole thing and make the adjustments for the font and for the size. Okay. And if you select the axis, you can also do it with that. So let me make it 12 and 12 here. Okay, and here you go. So let's call it done. So that's my graph. That's the example of what you should be able to achieve now. And that graph respects the norms of presentation. So now it's proper to get into a lab report, and hopefully that will have helped you to achieve that using Excel. So on that, I wish you a great day, and I look forward to speak with you again on the next video. Take care.